ever wondered where water goes when it goes down your drains in your house? It actually goes to a wastewater treatment plant. Hi, my name is Charity, and I'm an educator for King County Wastewater Treatment. Today, we're going to go on a tour of the wastewater treatment plant here in Renton. We're going to follow step by step and learn how environmental engineers have developed ways to clean all of the pollutants out of the water before it returns to the water cycle and the Puget Sound. Let's take a moment and think about it. What is wastewater? Wastewater is any water that comes down drains inside of buildings. So that could be showers, sinks, washing machines, dishwashers. It could be things coming from a factory too, or inside schools or office buildings. One thing with wastewater is that it's full of things other than water, right? It's full of organics, things like poop and pee and toilet paper. It's full of things like dangerous chemicals like cleaning products and personal products like medicine and makeup. It also has bacteria in it. Bacteria naturally occur in our body, things like E. coli, but could also be because we're sick. So things like dangerous germs could also be in wastewater. The last thing that we worry about in wastewater is trash. Trash is a huge issue for our system. You'll see later on in the tour what happens to all of the trash we have to take out of the water. I want you to take a minute and picture in your head, what do you think wastewater, what do you think raw sewage looks like? I actually have a sample of raw wastewater right here. We're going to take a look at it. So this is what we call raw influent. That means the water coming into the facility. When I first saw this, I was really surprised because I expected it to be really sludgy, right? Full of thick brown chunks. There are chunks in it, but most of what's in wastewater is water. So if you think about it, if the average person uses about 100 gallons of water every day, right? Most of what we're going to be receiving into the system is water. But all of those pollutants that I talked about, those could be really dangerous if they got out into the Puget Sound, which is why it's so important that we have a system that removes those things before we return the water to the water cycle. Here we are in the bar screen room that is 2 stories underground. The room contains 7 bar screens. Water flows through the bars on the bar screen. The bars are placed about a pinky nail width apart from each other, and as the water flows between the bars, the trash is caught. Things that get caught on the bars include tampons, condoms, and wrappers, as well as flushable wipes. The trash is then scraped off with the scraper arm and then dropped in the channel behind the screen. Once the screens catch the trash, it gets scraped up and then dropped into the channel behind the screens. Every year, King County spends millions of dollars dealing with trash clogs in our system. That's why it's important to remember the 4 Ps. The 4 Ps are the only thing that should be going down your toilet. Poop, pee, puke, and toilet paper. It's considered the primary step of the wastewater treatment process. In this step, we actually are using simple gravity to clean about 50% of the solids out of the water. So as you've seen, these huge tanks behind me are holding our wastewater, now free of trash. They're letting the wastewater sit, and the longer the water sits, the more it starts to separate. So I have a model in front of me. This isn't real wastewater, but inside of this bottle I have water, cooking oil, and sand. You can see really quickly that the sand, because it's heavier, sinks to the bottom, and the oil rises to the top. This cloudy layer in the middle is actually the cleanest layer of water. So like I said, this is a really passive, low energy way of allowing gravity to do the work for us. Once the water has been sitting in the tank, we scrape the sand off of the bottom. In this case, it's actually our organics, so our poop and our food. We scrape it off the bottom using these long scraper bars. We remove the oil from the top of the water using recycled water, gets sprayed over the top and pushes the oil over to the scum scrapers you saw earlier. Then the scum scrapers scrape the oil off of the top. So the clean water, that's that middle layer of our water in the tanks, actually gets pulled off from the tank by the bars behind me. So inside of these long troughs, there are holes that hit at about the middle of the water level. The water gets pulled into these troughs and then brought into the next step of the wastewater process. Leaving behind, again, the oil and the poop and the food at the bottom, so about 50% of those organic solids. The next step of the process is called aeration. In the aeration process, we pump hot air into the water, which activates special microbes that help clean the water for us. Then you'll see we let the water settle out again, and the microbes sink to the bottom. The hot air that we are pumping into the tanks behind me activate bacteria that are naturally occurring in our digestive system and occur in the water. Once the bacteria are activated, they grow in population to the point where they're saturating the entire water, and they create a complex ecosystem. So the bottom of our ecosystem, the bottom of our trophic level, are all of the nutrients and the poop and the food, right? The next level is the bacteria that are clumping together, creating something called a flock, and they're passively absorbing the nutrients from the water, kind of like herbivores in an ecosystem. We also have more complex creatures that are actively grabbing food out of the water, as well as grabbing the bacteria and feeding off the bacteria like a predator would in a forest ecosystem. The really cool thing about this ecosystem is that it's filled with literally thousands of different types of organisms. You can also take samples of this water and look at the assemblage of microbes, the different species, and use that to tell how healthy the water is, how healthy the ecosystem is, and how good of a job it's doing in cleaning the water. Vorticella is a type of stalked flagellate that acts as an herbivore in our complex ecosystem. They're a really interesting protist because they have long bungee cord-like tails that hang off of the bacteria flock in the water, then shoot out to collect food. Another type of stalked flagellate in the water is an epistylus. Epistyluses are passive filter feeders, like sponges, sea sponges. They live in colonies that look similar to bouquets of flowers, and they float in the water, passively absorbing the nutrients and the bacteria. After a few hours in the aeration tanks, the water gets piped on to the next step of the process. These are called secondary clarifiers. So at this point, our microbes have been eating the organics out of the water for us. But now we need to get those microbes and the organics they've collected in their bodies out of the water.
Water from the aeration tanks enters the clarifier from a centrally located pipe. Pumps pull the water up to the top of the tank, where it goes through a special device to slow it down and begin the settling process.
The microbes sink to the bottom and are then piped either back into the hot tubs or out into our digesters, where they're turned into a fertilizer. The clean water that's on the top then gets piped onto the next step, which is disinfection. So behind me is the last step of our wastewater treatment process here at South Plant. These long channels behind me are called contact channels. We're introducing a chemical, sodium hypochlorite, to the wastewater that'll remove any bacteria that may have escaped into the system, like E. coli. After the water has sat in the disinfecting channels for a while, it goes over what we like to call Renton Falls. These waterfalls aren't just for show, though. They're actually for an important water quality reason. As the water goes over these falls, we're introducing oxygen back into the water. It's really important that the water that goes out into the Puget Sound after this is high in oxygen because dissolved oxygen is incredibly important for the animals that live in the Puget Sound. So, like I said, this is actually the last time you'll see the water on our wastewater tour. From here, it gets piped 13 miles to a pipe that goes off of the coast of Alki in West Seattle. From there, the water is diffused under the pipe and slowly spreads out and then gets picked up and moved around by the ocean channels. When the treated wastewater leaves the treatment plant, we've removed a majority of those pollutants that were in the water when it entered the facility. Think back to the beginning of this tour. Remember those 4 categories? We have the trash, the organics, the bacteria, and the chemicals that are in the water. So we've completely removed the trash that's in the water. Think back to those bar screens earlier and that large amount of trash we saw in the pit. We've also removed all of the bacteria in the water, both through our aeration and through our sodium hypochlorite disinfecting channels. There are 2 categories, though, where some trace amounts are getting through our system, and it's important that we talk about it. The first thing that we have to think about is nitrogen and phosphorus, so nutrients, left over from the organics. These are naturally occurring nutrients in our food and then in human poop that come into our system, and many of them are removed from the water as our bacteria eat them up in aeration. However, some nitrogen and phosphorus does get through our system and goes out into the Puget Sound. The last category that we have to worry about is chemicals. Chemicals are broken down partially in our aeration process as bacteria eat them up and break them into their different parts. However, some chemicals are considered persistent. These are things like cleaners and pharmaceuticals that aren't broken down in our system, and trace levels are getting out into the sound. The easiest way and the most important way to control this is through something we call source control. That means that people are making choices where they live and where they shop, and manufacturers are making choices to not make products or use products that are going to be getting into the sound and are too persistent to get removed through the wastewater system. This means that you can actually do something to make our water cleaner. You can choose to use chemicals that are considered green or biodegradable and will break down in our system rather than going out into the sound and having a negative impact. Thanks for joining me on this tour of the South King County Wastewater Treatment Plant. Next up, you'll meet my colleague Kristen Covey at the Brightwater Wastewater Treatment Plant.
Welcome to Brightwater! Hi everyone, my name is Kristen Covey and I work with Charity on the education team for King County Wastewater. And you are at our newest treatment plant called Brightwater. And Brightwater came online in 2011, about 9 years ago. We're located in Woodinville, Washington. And because we are a newer treatment plant, we have a different secondary treatment system from South Plant, as Charity mentioned. The reason why we have a different secondary treatment system is so that we can clean the water to a higher level in order to reuse it instead of sending all of it out to the Puget Sound. So if you can remember, at South Plant, they had a process called aeration, or the bacteria hot tub. So we have that same process at Brightwater as well. And for us, it's located behind me, of those silver pipes. So one thing that's different about Brightwater is our tanks are all covered because we want to control odors. And so it's really hard to show you what the tanks look like, but just know that that's where aeration is happening at Brightwater. So the bacteria are consuming and eating everything, they're getting really fat, and instead of putting that water into secondary settling tanks like they do at South Plant, we instead put it into another set of tanks, which are located over here, that contain microscopic filters. So underneath that area are the filters, and we're going to learn how they work next. So remember, what we have left in the water at this point is a lot of bacteria, chemical compounds, and some other microscopic particles, right? So if we have filters in these tanks, they're going to need to be pretty tiny, right? So I'm going to show you the filter technology that we have here. You might be surprised at what it actually looks like. You ready? Here it is. this is the technology we have here. And how does this work? So here we are standing on top of the tanks that contain all of the filters. You can see that behind me. They're covered right now, so you can't see inside the tank, but if you were able to, you would see what you see in this photograph. So this is what we would call a membrane filter cassette. So this is one of them, and we have 160 of these in all of the different tanks. So when I say the word membrane, what does it remind you of? Have you heard of that word before? So it's pretty cool because a membrane is what is on the outside of a cell. So it's the outer coating of a cell, and it's selective. So it allows certain things to go in or out. So we have basically mimicked a cell membrane in this technology, but the limiting factor for this technology is size. So in this case, the only things that are going to fit through this filter have to be small enough to pass through teeny tiny pores or holes in this filter. And I'm not talking about the holes at the end, which means that there are actually microscopic pores in this plastic that you can't see with your naked eye. So that means that this straw is a filter, and the filtering part of the straw is the plastic. So anything that goes through this plastic ends up in the center of the straw and gets extracted. So these pores are so tiny, they're only 0.04 microns, which might mean something to some of you, but for most of us that means nothing. So what means something to me is that if I were to line up 2,000 of those pores side by side, so 2,000 in a line, the width of that could fit across a human hair. So that's tiny, which means that only a water molecule, or anything smaller could pass through one of those pores, which means that the bacteria do not go through this filter and they stay on the outside. Okay, but so how does the water actually get pulled through the plastic and into the center of each filter? So if you can remember, here's the cassette, right? So it's submerged vertically into these tanks behind me, and on top of each cassette is a vacuum pipe pulling upwards. And you can see the pipes behind me. So each cassette has one pipe that pulls upwards, that provides a suction. So when that happens, it's going to pull into the center of each filter just whatever can fit through those pores. So just the cleanest water will go through into the center and get extracted out by that vacuum pipe. So this is a very valuable freshwater resource that we can reuse for certain purposes, which you're about to learn about, but most of it still does go into the Puget Sound. So let's go check out the waterfall that we have here at Brightwater to see the water leaving the plant and going into the Puget Sound.
Hi everyone, I'm Sienna and I'm an educator with King County Wastewater Treatment Division. I'm going to be talking to you all about how we recycle resources from our wastewater. Treating wastewater requires lots of energy to pump all the millions of gallons of wastewater around our system every day. So at King County Wastewater Treatment Division, we think a lot about how to be sustainable and reduce our energy consumption and reuse the valuable resources that are already in wastewater. Thinking back to the organic material, such as the poop and food that was removed from primary and secondary treatment, you may have wondered, where does that go and what happens to it? So these big tanks behind me are called digesters, and all the organic material is sent into these tanks. So that material spends 2 weeks or so in these tanks getting broken down by naturally occurring anaerobic bacteria. And these tanks are heated to 98 degrees, so it actually is the same temperature as our bodies, and that process of breaking down the organic material is similar to what happens in our stomachs. As the anaerobic bacteria breaks down the organic material and consumes it, they give off a few different gases, including methane gas. Now, methane gas is actually a greenhouse gas, and so it contributes to climate change. So instead of letting that gas just escape into the atmosphere, we actually capture it here, and we call it biogas. So you can see those black pipes behind me are actually where that methane gas is getting removed from the digesters. It's then going to get scrubbed and cleaned and used to heat the boilers here at the treatment plants, as well as it's going to be sold as natural gas to help heat and fuel energy in people's homes. Follow me to see what happens with all the organic material from the digesters. All the organic material comes to this room where it's spun through a centrifuge, which removes the water from it, and next we're left with this biosolid. It's full of nutrients and organic matter. What do you think we use it for? So King County's brand of biosolids is called Loop. And in fact, you may have seen one of these trucks traveling on the I-90 corridor east, where it's bringing this material to farms and forests in eastern Washington to help grow trees for timber, as well as canola, wheat, apples, and hops. In addition to providing nutrients to plants, Loop helps build healthy soil that retains more moisture, which is especially great in eastern Washington where it's drier and hotter. So businesses that use Loop go through a permitting process because there are a small amount of pathogens left in the material. That just helps make sure that the product is used safely and doesn't cause any problems. Something that you may not know is that every year King County produces 120,000 tons of Loop. That's enough Loop to fill a football stadium 70 feet high. Thanks for your contribution. So we turn a small portion of Loop biosolids into a compost that's sawdust mixed with Loop, and it can be used at home gardens as well as here at our demonstration garden to grow fruits, plants, and flowers. So what about all that cleaned effluent or treated water that goes out to Puget Sound? Couldn't we reuse some of that? The answer is yes. We actually send a small portion of that water through an additional treatment process, which is a sand filter, and it ends up as something called recycled water. And it looks like this. To the human eye, you actually can't really tell that it's any different from drinking water. But it's not drinking water. It has to travel in its own set of pipes, which are always purple in color. Recycled water is great for irrigation of farms and sports fields. It's also used for street cleaning. It can even be used for flushing toilets in certain facilities, as well as industrial water. A fun fact is that the Seattle Sounders practice on Starfire sports, and their fields are also watered with recycled water. Recycled water is also great because it still has nutrients in it, so it can actually add a fertilizing boost to the plants that it's irrigating. And in terms of the pipes it has to travel in, recycled water can't travel in the same pipes as drinking water, so if a business wants to use it, they need to help build out purple pipes to their facility, or they can come to one of our truck refill stations and pick up recycled water and take it to their facility. Using recycled water is really helpful for our planet because it puts less pressure on the streams and aquifers that we get our drinking water from, which means there's more water left for drinking and for salmon and other wildlife to use. So now you've learned about how we reuse organic material, some of the water, as well as the biogas energy from our wastewater treatment process. This is an effort to help reduce our carbon emissions and environmental footprint by building healthy soils, keeping more water in rivers and reservoirs, and creating renewable energy sources.